This is AWR Microwave Office tutorial series. In this video, we will learn to construct a circuit schematic which we can use to simulate slotted transmission line in AWR. So let's get started. In the first step of this video, we are going to open AWR design environment. And before creating the schematic, we are going to set up the project options. To do that, we'll go to project window, and here we have to double click on project options tab. Make sure you have selected the frequencies tab from project option window. In this simulation, we are going to simulate for single point frequency. So we'll select that, and the single point frequency in our case will be 2 GHz, and we'll click over apply button. So as you can see here, the current frequency has been selected. Now we'll click over OK. Now before closing this, we are going to set some global units. To do that, we'll just go to global units tab, edit units, and make sure you have selected the gigahertz from the frequencies tab, and click over OK and apply. The rest of the settings will be by default. Next, we are going to set up circuit schematic. To do that, we'll go to circuit schematic in the project window, right click and click over new schematic. I'm going to name this slotted transmission line and click over create button. Then we are going to place two transmission lines which will be TL-IN. To do that, we'll just hit Ctrl L on our keyboard, and by that we can able to access the library components. Now here I'm going to type TLIN-P, and this is the one which we are going to use, which is a physical specs of grounded shield transmission line. We'll click over OK. We'll place one here. It's Ctrl C and Ctrl V. We'll place another here. Now if I'll connect these two transmission line through a wire, the simulator will consider it as a one unit. Alright. So for example, here we have 10 mm of transmission line 1 and 10 mm of transmission line 2, and if I just connect this, so simulator will understand this a 20 mm transmission line with 50 ohm of its characteristic impedance, which we don't want. We want to create a slot here, and if you'll see from the measurements point of view, for standing waves, the maxima and minima, if you can see in the picture, we slide our cursor on the transmission line to locate Vmax and Vmin, as you can see. So similarly, in case of slotted transmission line, we have to measure the voltage and the current at the point of transmission line. As you can see, I want to measure at that point. So to do that, we have to sort of create a slot using the voltmeter and a current meter. All right. To do that, I'm just going to delete this line, and I'll place one current meter first. So to do that, we'll just hit Ctrl L and search for meter, and here we have this current meter. We'll just click over this. I'm going to place it somewhere here. Make sure the direction of the current should be in the correct direction. Let's connect this, and to place a voltmeter, again go back to Ctrl L, and this time we'll select this V meter, and this should be placed here. Let's connect that as well. And don't forget to add the ground at the negative terminal of the voltmeter. In the next step of this video, we are going to define all the global variables like we did in the previous tutorial. To do that, we'll go to Global Definition tab, and here we are going to place the equations. So let's place our first equation, and there we are going to define the total length of the transmission line. Let's make it 100 mm. So just remember that this L is equal to 100 mm. This is a total length of two transmission line combined. All right. And another, we are going to define a variable. Let's make it 10 mm by default. And this is a sort of virtual slot variable in the transmission line, and which represent the position of the slot. So now we'll go back to the schematic. And for the transmission line 1, we are going to define the length to X variable. And for transmission line 2, we are going to define it by L minus X. And here probably you have already guessed, we will use X variable on the tuner and move the slider to see the effect of change in length in the simulation. And since these I meter and V meter, these are ideal meters, so there will be no discontinuity in the transmission line because of these. All right. So next we are going to add ports on this. To do that, we'll just go to ports, and you can just go to elements window, select ports from here. We are going to place harmonic balance port. So just select that. and we'll place one tone port. So just drag it and drop it here. Make sure the impedance of the port should be 50 ohm. And we are not going to set any power here, so let it be by default 0 dBm. And at the output we are going to place a termination register, and to do that we'll just go to our library, search for register, okay, rotate it, place it here, and its value make it 50 ohm. So this is 50 ohm terminated, and don't forget to add the ground at the other side of the register. Alright, so we have our schematic ready. Next we are going to set up the graph. To do that, go back to project window, go to graphs tab, right click, click over new graph. Make sure you have selected rectangular and click over create button. Next we are going to add measurements. To do that, we'll right click, go to add new measurements. From here we are going to select non-linear because we are going to plot for voltage and currents. So first we are going to select voltage. So let's select voltage here. And here we are going to select VComp, which is the voltage for harmonic components. Make sure to select the right schematic here. And the measurement component will be V meter. So let's select that, click over OK. And the harmonic components we are going to simulate for 1 gigahertz. So let's select 1 here and click over add. Next we are going to add the measurement for current. To do that, from the non-linear options, we are going to select current here. And similarly, we are going to select IComp, which is for harmonic component. Here we have to select the current meter. Frequency will be 1 gigahertz. And click over add button. Next, we are going to run the simulation. To do that, we'll click over this, apply. And here you can see the blue marker represents the voltage components. The pink marker represents the current component. So it is difficult to see the value of exact voltage in this y-axis. So we are going to make it 3-axis plot. We'll right click over graph, go to options, and here we'll select the axis properties. We'll select the left one, make sure auto limit should be selected, make it 0 to 10. So we'll just remove this and make maximum value to 10. We'll select right, remove the auto limit and make it 0 to 1. Remove this auto scale while tuning, and from here as well, and click over apply. So here we can see the voltage is approx 0.3 volt and the current will be flowing on the transmission line is approx 6.5 amps. All right, we can add marker here as well. To do that, we'll right click, go to add marker. I'll put one marker here, right click, add another marker, we'll put on. So as you can see, the current is in milliamps and voltage is in volt. So the current is approx 6.325 milliamps and the voltage on the transmission line is 0.3. Next we are going to save this project. To do that, we'll go to file, save project. We are going to save it on desktop. Let's rename it slotted line and click over save button. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.